Series of learning aerodynamics, let us discuss more on aircraft performance. In the previous video, we have discussed about minimum drag conditions. So, how to calculate the minimum drag conditions, or how to find out the minimum drag conditions for the lift coefficient and drag coefficients. From that, okay, we just saw that CL minimum drag equal to square root of CD naught by K, and CD minimum drag equal to twice CD naught. So based on this, we can get the one more relationship, that is nothing but L by D. So that means L by D, this L by D maximum. So L by D maximum is nothing but CL max, or we can just say CL minimum divided by CD minimum. So that's what, okay, in the previous this we have seen. So we can just apply this values, so then we can get this one. So CL minimum is nothing but square root of CD naught by K, then by twice CD naught. So then this further can be simplified. We can just have this term, because this is nothing but when we are taking this into the this equation, the square root of CD naught by this goes to this one, 4 into 4 into K CD naught square. So this is what, so see, this will get cancelled. So we will have a this 1 by 2 K CD naught. So this is what, okay. So yeah, so after simplifying this terms, and then L by D maximum is nothing but 1 by twice into square root of 2 K CD naught. So this is okay from the equations, or from the analytical this calculation or analytical derivations. So we will see how to find the L by D maximum from the graph. So L by D maximum from the graph can be found out if you draw the graph between CL by CD. If we draw the graph between CL, this is okay, vertical axis is nothing but CL, then horizontal axis is nothing but CD. So if you are drawing the curve between these two, then this will be something like this. We will have we will be having this kind of curve, this kind of graph. So when we are finding the CL and CD from the experiment, then CL and CD, then with respect to that the graph will come something like this. So this is what, okay, so here in this what we can do, we can just have we can find the L by D maximum. L by D maximum we can find out in this. How to find out the L by D maximum? That is nothing but we have to draw the tangent to this curve. We have to draw the tangent to this curve. So that means highest ratio of the L by D. Highest ratio of the L by D gives the best L by D ratio. That is what, okay, we can say maximum L by D ratio. So highest ratio of the CL by CD will give the best L by D ratio. So if I'm just if you are drawing the if you draw the tangent to this curve, then this point, okay, this point we can say as the this point will give the this point only will give the best L by D ratio. That means L by D maximum. This gives the L by D max. So because we can just check out because from this graph we will be knowing okay, so this is 0, so we will be knowing the data. So if you take the different values in CL and different values in CD, and then if you find out L by D ratio, then maximum L by D ratio can be or will be achieved at this point. So that's what we say this. So this is gives the that means another idea for achieving optimum aerodynamic efficiency. Optimum aerodynamic efficiency is achieved so with the help of highest optimum aerodynamic efficiency. So because aerodynamic efficiency is given by this one. So L by D ratio is nothing but it gives the aerodynamic efficiency. So because maximum value of the L by D ratio is nothing but the optimum, that means that gives the optimum aerodynamic efficiency. Also this L by D ratio maximum is the we from this okay, or we can say best glide ratio. So in the glider flight this L by D maximum will be utilized. So for the best gliding ratio, for best gliding conditions, then this condition will be used. So this also we can say best glide ratio. So L by D maximum also gives the best glide ratio. We can say best glide ratio. So this is how okay we are achieving the maximum L by D ratio from the graph, and theoretically we have seen how to achieve the L by D ratio max. So that is nothing but this is L by D ratio max based on the theory. So that is nothing but 1 by square root of 2 into K CD naught. So this is what okay we have seen in the previous, means we have seen from the derivation, and then from the graphical analysis or graphical method we are finding the L by D maximum by drawing the tangent to this curve. From the origin we are drawing the tangent, then we are getting the L by D maximum. So this also we can say as the that means drag polar aircraft drag polar. This curve also called aircraft drag polar or okay drag polar flat, because drag polar equation is different and drag polar flat is different. Because drag polar equation we know CD equal to CD naught plus KCL square, and whereas this is called a drag polar flat, okay, or a drag polar graph. So I hope okay how to achieve the L by D ratio from the graph and also from the analytical or theoretical calculation. So I hope it is clear. We will see more about performance in the next video.